What if the universe had a cosmic undo button?
An undo button.
Yeah, like imagine a place where instead of everything getting sucked into oblivion, it all just explodes outward.
Okay. Yeah.
Could something that bizarre actually, exist? That's the kind of mind-bending question we're tackling today.
Exactly. We're diving deep into the theoretical realm of white holes,
White holes.
often thought of as the polar opposite of black holes, the ones we hear so much about. It's a truly, well, sci-blowing idea, right? Bubbling up from astrophysics.
And this deep dive, it's kind of inspired by some fascinating concepts we've been digging into, especially things highlighted on the Sci-Blowing podcast.
Right.
So our mission today, let's try and unpack this whole enigma of white holes. What are they supposed to be?
Uh-huh.
What's the science that even allows for them? Why has physics been, well, pretty skeptical?
Yeah, historically very skeptical.
And the really big one, what if they are real? What are the cosmic implications? So, yeah, prepare for a journey to the far fringes of what seems possible.
Definitely. But look, before we can really wrap our heads around a white hole, we absolutely need to get grounded in its more famous sibling, the black hole.
Right. Start with what we know.
Yeah.
Or think we know.
Exactly. So a black hole, simply put, is a region in space-time where gravity is just so incredibly intense that absolutely nothing,
Nothing.
not a thing, not even light can escape its pull once it crosses a certain boundary.
The event horizon.
The event horizon, precisely. And these things, they typically form when really massive stars collapse at the end of their lives,
Okay.
creating this ultimate point of no return.
Like a cosmic one-way street. You check in, but you don't check out.
That's a good way to put it.
But this isn't just like a cool theory, is it?
Yeah.
We actually have proof these things are out there.
Oh, absolutely. The evidence for black holes is, well, it's substantial now, and it keeps growing.
Like what kind of evidence?
Well, for starters, we've detected gravitational waves, ripples in space-time itself.
From LIGO, right?
Yeah, projects like LIGO and Virgo. Often these waves come from black holes colliding. Huge events.
Wow.
And we've also tracked stars orbiting something invisible at the center of our own galaxy, the Milky Way.
Sagittarius A.
Sagittarius A, exactly. They're moving at incredible speeds around something supermassive that we can't see directly.
Which implies a black hole.
The best explanation is a supermassive black hole, yes. And then there's the really amazing visual evidence from the Event Horizon Telescope.
Oh, yeah, the picture.
That incredible image of the shadow cast by the supermassive black hole in galaxy M87. It's a pretty direct confirmation.
So, okay. Black holes are definitely a thing. A cornerstone of astrophysics, you could say.
No doubt about it.
But you mentioned earlier the same math, the same theory that describes these things. It also hints at something else, something backwards.
Precisely. That's the crux of it. Einstein's theory of general relativity, the bedrock for understanding black holes, mathematically contains a time-reversed solution.
Time reversed.
Think of it like the equations themselves have a kind of symmetry, a built-in mirror image. And that theoretical mirror, that's where the white hole concept comes from.
So the math just spits it out as a possibility.
Essentially, yes. In fact, Einstein himself, way back in 1935, working with Nathan Rosen, explored some related ideas about space-time structure, these sort of bridges.
The Einstein-Rosen bridge.
Exactly. So the theory that works so well for inescapable gravity also, mathematically at least, opens the door to the exact opposite behavior.
Okay, all right. Let's step through that mathematical door then.
Yeah.
What exactly is a white hole, theoretically speaking?
Okay, so in simple terms, a white hole is theorized as a region of space-time that acts like a source, a point of expulsion.
Expulsion.
Yeah, where a black hole is a place nothing can escape from, a white hole is a place nothing can enter into.
Nothing can get in.
According to the pure mathematical solution, no. But energy and matter can freely emerge from it.
So it's constantly spewing stuff out.
That's the picture, like a universal pressure valve, maybe? Constantly ejecting material.
So if a black hole is like that cosmic drain, a white hole is like a cosmic geyser, just shooting things out.
That's a fantastic analogy, yeah. A cosmic geyser. Within the math of general relativity, specifically in what we call the maximally extended Schwarzschild solution.
Okay, that sounds complicated.
It is. It's the most complete theoretical picture for a simple, non-rotating, uncharged black hole. The white hole appears mathematically as the time-reverse twin of the black hole.
Time reverse twin.
So if you think of a black hole as space collapsing inwards towards a singularity in the future,
Right.
you can visualize the white hole as space expanding outwards from a singularity in the past.
In the past. Okay, my head's starting to spin a little. This maximally extended solution, what else does it predict besides this black hole, white hole pair?
Well, this is where it gets even more speculative and bizarre. The
Yeah.
full mathematical structure suggests not just the black hole and the white hole,
Okay.
but also a potential connection between them, a wormhole.
The Einstein-Rosen bridge you mentioned?
That's the one. Theoretically linking the interior of the black hole to the interior of the white hole.
Whoa.
And even more mind-bending, the math hints that these structures might connect to entirely separate universes.
Separate universes. Seriously?
Theoretically, yes. It's a potential consequence of taking the mathematics of the Schwarzschild solution to its absolute limit. Fascinating, but highly, highly speculative.
Separate universes, cosmic shortcuts. I mean, it sounds like straight-up science fiction. But
Nice.
okay, if the math allows this, why haven't we just, seen one with all our telescopes?
Yeah, that's the million-dollar question, isn't it? While the math is there providing this possibility.
Which is no sightings.
Exactly. Zero direct observational evidence for white holes. None whatsoever. And that absence of proof is, understandably, a huge reason why many physicists are very skeptical about them being real physical objects.
Okay, so the equations say maybe, but the sky says nope, haven't seen one. What was the big hang-up for so long? Why were they kind of dismissed?
There were some pretty major theoretical roadblocks, fundamental issues.
Like what?
Well, one big one was the second law of thermodynamics.
Entropy. Things tend towards disorder.
Precisely. Entropy or disorder in a closed system tends to increase over time. A white hole, though, constantly ejecting what you might think of as ordered matter and energy.
Well, it seemed to violate that fundamental law pretty blatantly.
It's creating order out of nowhere, essentially.
That was the concern, yeah. Plus, other theoretical studies suggested they'd be incredibly unstable.
Unstable how?
Like any tiny bit of matter or even radiation falling towards it from the outside universe would likely cause it to immediately collapse.
Collapse into what?
Into a black hole, ironically. The very act of interacting with the outside universe would destroy it.
Huh. So they're like these delicate mathematical flowers that would wilt at the slightest touch from reality.
Sort of, yeah. That was the prevailing view for a long time. They were seen more as a mathematical artifact, a quirk of the equations, rather than something that could actually persist in the real universe.
But you said interest has been renewed. Something about quantum gravity. Yes, exactly. More recent ideas, especially coming out of quantum gravity research fields like loop quantum gravity or LQG, have offered some, well, intriguing new ways to think about them.
Loop quantum gravity.
Okay.
What's the core idea there?
So LQG suggests that when you get down to incredibly tiny scales, like near the supposed singularity at the heart of a black hole, quantum effects take over.
Quantum effects stop the singularity.
They might prevent the formation of a true point of infinite density. Instead of a singularity, these quantum effects could cause a kind of bounce.
A bounce, you mean the stuff falling in hits some quantum wall and bounces back out.
That's the essence of the idea. The infalling matter and energy get compressed to an extreme quantum state and then violently rebound outwards, potentially into a new region of spacetime.
As a white hole.
As something behaving like a white hole, yes. Ejecting the contents that fell into the black hole, though probably in a very scrambled, very delayed way. This is central to work by people like Carlo Rovelli and Francesca Vidotto.
So it provides a potential mechanism for how a white hole might actually form from a black hole.
It offers a plausible physical scenario rooted in quantum gravity, yes. Instead of just being an eternal mathematical twin, it becomes a possible endpoint or transformation of a black hole.
That's, wow. Okay, and you also mentioned tunneling. Black hole to white hole tunneling.
Right, that's another related idea. Some models propose that black holes might not be stable forever. Over incredibly vast timescales, maybe longer than the current age of the universe, they could quantum mechanically tunnel or transition into a white hole state.
Tunneling, like in quantum mechanics where particles can pass through barriers.
Kind of analogous, yes. It's a quantum process. And this idea, explored by Hal Haggard and Rovelli, among others, is particularly interesting because it might help solve the black hole information paradox.
The information paradox. What happens to the information about stuff that falls in if the black hole evaporates?
Exactly. Hawking radiation suggests black holes evaporate, seemingly destroying the information. But if the black hole eventually tunnels into a white hole,
The information could come back out.
Potentially, yes. The white hole phase could be the mechanism by which the information is released back into the universe, preserving a fundamental principle of quantum mechanics.
Okay, so instead of instant death at the singularity, it's like this delayed, quantum-fueled rebirth as a white hole, releasing the information.
Right.
That's a major plot twist.
It really is.
And then there was that even wilder idea,
Yeah.
the Big Bang itself. Could that have been a white hole?
Okay, now we're getting into much more speculative territory. But yes, some cosmologists have played with the idea. Could the Big Bang, the start of our observable universe, have actually been the explosive output of a white hole?
How would that even work?
The thought, very roughly, is maybe a black hole formed in a previous cosmic era, or maybe even another universe entirely, underwent this quantum bounce
And boom, our universe comes out.
and expelled its contents, creating the expanding cosmos we see. It's a radical idea, lots of debate, lots of open questions, but it shows how profound the implications could be if white holes, or something like them, are real.
From tiny bouncing black holes to the origin of everything. That's quite a scope. Let's maybe zoom in a bit. Back to this idea of white holes as exits from black holes. Is that seen as a serious possibility?
Well, it flows quite naturally from that theoretical connection we talked about, the maximally extended Schwarzschild solution, where they're mathematically linked.
The wormhole link.
Potentially, yes. The core idea is maybe something falling into a black hole doesn't just hit a singularity. Maybe it undergoes this quantum bounce
Yeah.
and then reemerges, maybe much later, maybe somewhere else entirely, through a white hole.
So the black hole is the entrance, the white hole is the exit, possibly connected by a wormhole.
That's the conceptual picture.
So you could, in theory, fall into a black hole here and pop out of a white hole like across the universe, or even in a different time. Talk about cosmic jet lag.
Hey, indeed. It would be the ultimate shortcut if it worked. It connects directly to wormhole theories, offering these hypothetical tunnels through space-time.
Faster than light travel,
Right.
essentially.
Well, a way to bypass the vast distances, certainly. Whether it's practical or stable is another massive question.
And connecting back to the information paradox puzzle, if stuff can actually get out through a white hole exit.
Then the information isn't necessarily lost, you see.
Right. It just took a very weird detour.
Exactly. It provides a mechanism for information conservation, which is crucial for making quantum mechanics and general relativity play nicely together. That's a huge motivator for exploring these models.
Okay. So theoretically, white holes could be these amazing escape hatches, information savers, maybe even universe generators. But the huge question is still hovering there. How on earth would we find one?
Yeah, the detection challenge is immense.
Because nothing can go in, right? So it's not like we can see stuff falling towards it.
Precisely. Their whole deal is expulsion, not attraction. So you need to look for what they emit, not what they pull in. But theorists have proposed a few potential signatures, things we might look for.
All right, hit me. What weird stuff should astronomers be keeping an eye out for?
Okay, one possibility. Sudden, powerful bursts of energy, but coming from apparently empty space.
Empty space?
Yeah, since nothing can fall in to trigger the burst, it would just appear, seemingly out of nowhere, from the white hole itself.
A spontaneous explosion. Okay, what else?
Maybe look for radiation that has very high entropy, very disordered, but with no obvious preceding event, like a supernova, to explain why it's there.
Disorder without a cause.
Also, maybe unusual gamma ray bursts. Bursts that don't quite fit the profile of the ones we know come from collapsing stars or merging neutron stars.
Something off about them.
Something different, yeah. Another idea involves primordial black holes.
Tiny black holes from the early universe.
Exactly. If those exist, and if they undergo this bounce, maybe we could detect the transition or the white hole phase they enter now.
The afterglow of a primordial black hole turning into a white hole.
Wow. And perhaps the most talked about potential candidate recently.
Yeah.
Fast radio bursts, or FRBs.
FRBs, those super intense millisecond-long radio signals from deep space.
The very same. They're still a big mystery. Some researchers, like Aurélien Barraud and Ravelli, have speculated, and it is speculation that maybe, just maybe, some FRBs could be emissions from white holes.
Cosmic burps from white holes causing FRBs. That's a wild thought.
It is definitely wild, but it connects a known, puzzling phenomenon with this highly theoretical object. It gives astronomers something specific, albeit speculative, to consider.
It certainly makes FRBs even more intriguing. Okay, so let's say, hypothetically, we find convincing evidence. A signal that screams white hole,
Yeah.
What would that mean for our big picture view of the cosmos?
Oh, the implications would be absolutely profound, game-changing.
Like how?
Well, as we touched on, confirming them, especially if linked to black holes, could lend serious weight to the idea of wormholes, maybe even portals to other universes, like the math suggests.
That alone would rewrite everything.
Absolutely. And they might offer completely new ways to explain some of the universe's biggest mysteries.
Like dark matter. You mentioned that.
It's been tentatively suggested. Could remnants of primordial black holes transitioning into white holes contribute to dark matter? Or maybe white hole dynamics played a role in cosmic inflation right after the Big Bang? These are very out there ideas, but a discovery would open up these lines of inquiry.
So these hypothetical objects could suddenly become key players in understanding the universe's biggest puzzles.
Potentially, yes. And think about the end state of black holes. We usually talk about Hawking radiation and eventual evaporation.
Right, fading away over trillions of years.
But if they can transition into white holes instead, that suggests a totally different kind of cosmic recycling program. Matter and energy aren't just radiated away diffusely, they might get ejected more dramatically.
So not a fade out, but maybe a final explosive act.
Perhaps a second act, yeah. And even philosophically,
Go on.
the existence of white holes would suggest a universe that isn't just about collapse and things running down. It would mean there are also regions of powerful expulsion, maybe hinting at cycles, maybe even a kind of reversibility on the largest scales.
A more dynamic, maybe less one-way universe than we thought.
Exactly. A cosmos that might be far stranger and perhaps more symmetric in time than we usually imagine.
Okay, so let's try and bring this all together. White holes? The theoretical mirror image of black holes,
Right. Allowed by the math of general relativity.
but zero direct sighting so far.
Correct. Still purely theoretical in that sense.
But cutting-edge ideas from quantum gravity, like loop quantum gravity, they offer ways they might actually form, like black holes bouncing or tunneling into them.
Plausible mechanisms, yes.
And if they exist, they could be escape hatches from black holes, maybe linked by wormholes, maybe solving the information paradox.
Key theoretical motivations.
To find them, we'd look for weird energy bursts from nowhere, unexplained high-entropy radiation, odd gamma-ray bursts, or maybe even FRBs.
Those are the potential, though challenging, signatures.
And the big picture implications. Mind-blowing. Portals to other universes, maybe explaining dark matter or inflation, a different end for black holes, maybe even suggesting the Big Bang was one, pointing to a cyclical dynamic universe. That's a lot.
It is indeed a huge amount to ponder, and those fundamental questions, they are still wide open, very tantalizing.
Are they real? Just math?
Or are they just mathematical curiosities, elegant solutions on paper, or are they genuine physical objects out there in the cosmos, however bizarre?
Could they really be escape routes?
Could you actually escape the ultimate prison of a black hole through one?
And what do they tell us about everything else?
Yeah, will their existence, if confirmed, force us to fundamentally rewrite our understanding of space, time, gravity, quantum mechanics, the whole shebang?
It really forces you to question, well, the nature of reality itself, doesn't it?
It does.
Just the thought that somewhere out there, or maybe connected in some deep way to the black holes we do know about, there could be these fountains of creation spewing out energy, seemingly running gravity in reverse. It's just a powerful reminder, I think, that the universe is probably way, way stranger and more full of surprises than our current science can even fully comprehend.